Okay, so far we have covered the module 1, module 2 and module 3 of this machine learning subject, the subject code BCS602, important questions and previous year question paper and overview of the each modules. So in this video we are going to discussing about the module 4 important concepts and the question answers. So let's start. In this module 4 there are two chapters, Bayesian learning and artificial neural networks. The chapter 1 Bayesian learning contains introduction to a probability based learning, fundamentals of bias theorem, classification using a bias model, naive Bayes algorithm for a continuous attributes. And in the module, chapter 2 artificial neural network, that contains the introduction part, biological networks, new artificial neurons, perceptron and learning a theory, types of artificial neural networks, popular applications of artificial neural networks, advantages and disadvantages of this ANN, then challenges of ANN. So in this chapter 2 it is almost all theory content is there, guys. So without wasting time, let's get start one by one. Okay, the first question is, define a prior probability, explain Bayes theorem, HML and HMP with an example. So you need to define the prior probability. So the prior probability, it is the general probability of an uncertain inner event before an observation is seen or some evidence is collected. That is a P of H. P of H we can write in right there. No, that is, so it is the initial probability that is believed before any new information is collected. You just go through this definition, and here I have written a posterior probability definition as well. As in the question, define prior probability is there, so you just go through this definition and let's see the Bayes theorem. Okay, so before that, HML and HMP, what it means, definition we'll see here. Definition is there. So maximum a posterior map, that is a hypothesis of HMP. HMP is nothing but a maximum posterior of a hypothesis. So definition is there, then equation is there. You just note this equation and read this definition. Okay, similarly maximum likelihood, that is ML, hypothesis, that is HML is there. So for this also we have a definition along with the expression. Then comes the Bayes theorem. So to prove or to explain this Bayes theorem, this is the example, guys. Okay, so I will add this PDF in the description. You can read. Okay, so let's see the second question. There is analyze the different types of artificial neural networks with the diagram. So the types of artificial neural networks are, there are four types. Before that, this artificial neural network consists of a multiple neuron arranged in a layers. Okay, that theory content is there. Then the first one is feed forward neural network. So the feed forward neural network, this is the simplest neural network that consists of a neurons which are arranged in a layer, and the information is propagated only in the forward direction. See, the it contains the input layer, hidden layer and output layer, three parts. And especially in the feed forward neural networks, the arrow mark is only forward direction, not a backward direction. Okay, so this backward direction is not there. That is a feed forward neural network. Second one, fully connected neural network. Fully connected neural network, networks are the one in which all the neurons in a layer are connected to the all other neurons in the next layer. The title itself says that a fully connected, the connection between each neurons are connected. That is the description is there. Okay, then third one, multi-layer perception. So this is a this artificial neural network consists of a multiple layers with a one input layer, one output layer and one or more hidden layers. So here in the hidden layers we have a multiple hidden layers, and but having only one input, then only one output. Okay, fourth one, feedback neural network. It have a feedback connection between a neurons that allows the information flow in a both direction in the network. So the diagram is there. If you understand this diagram, then you can easily able to explain these types. Okay, let's see the third question. Explain the simple model of artificial neural along with the artificial neural network structure. So explain simple model of artificial neuron along with the artificial neural network structure is there. It is also theory content is there, just a simple model of artificial neural networks. It mathematically modeled biological neurons was designed by MC Charles and Pitts in 1943. It includes the two steps. It receives the weight and inputs from the other neurons. Then it operates with the threshold function, or activation function. Okay, the received input are computed as a weighted system, which is given to the activation function. And if the sum exceeds the threshold value, the neurons get a fired. So one you can also read this one time. Okay, so then you will understand. And this diagram, that simple model diagram is there. So this is a diagram. Then what are the expression w1 w2 are the all are written here. Okay, so then the artificial neural network structure is like this. So like this diagram is there. Moving on to the next question, define activation function. Explain in different types of activation function. It is important. There are 9 activation functions are there, guys. Okay, so you need to go through one by one explanation. Before that, activation function definition we'll see. The activation function are the mathematical functions associated with each neurons in the neural network that maps input signals to the output signals. And there are 9 types. 9 types. First one is identity function, that is f of x equals to x for all x. So wherever x increases, that proportionality with the value of x will also increases. Second one is a binary function. So the output of output value is a binary. So that is 0 and 1 based on the threshold value theta. Then third one, bipolar function is the expression is given here. Fourth one, sigmoidal function. Then sigmoidal function is also called a logical function, that the expression is given here. Then fifth one is bipolar sigmoid function, that is a sigma of x, then 1 minus e of minus x, then 1 plus e raised to minus x. Sixth one, the RAM function is there. Again, along with the expression, you need to explain. Tan hyperbolic tangent function is the seventh one. Here expression is there. Then one line description is there. Eighth one, ReLU rectified linear unit function. Okay, and ninth one, softmax function. Yeah, expression is there. Then you just need to understand this expression, and you need to explain each function with a description. Then let's see the fifth question. Use an naive Bayes classifier to classify the data given by red SUV domestic and using the training data given in the table. Here you need to, it is a problematic numerical problem based question you need to solve. The data table will be given in the question paper itself. If it is asked regarding about naive Bayes, based on, you need to start, you need to solve. Here you need to find the probability of yes. So the number of probability 1 2 3 4 5 5 yes are there. So 5 divided by out of there are totally 10 instances, 10 numbers are there. No, you need to write that 10 out of 10, only 5 we have, that is the probability of s is 0.5. Similarly, other than that, other than s, all are no. So again, 5 divided by 10, 0.5, these are the probability of no. Then you need to find the color of red, yellow, then s no quantity table. So here red, how many colors having a red with the stolen yes. So this is the red having s1, this is the red having s2, this is the again red yeah, here red is there, here no, it is not considered red, here yes. So 3 reds are there. 3 by 5. Similarly, nose are two nose. See, red no, one no, red two no. So 2 by 5. Like that only you need to find the yellow. Like that same you have to make that tabular column for a type and origin. So type and origin you need to find the for s and number of s's and number of nose probability. Okay, so once you draw this table, then you need to resolve solve the probability of yes with the given instances. They have given the instances with a red, SUV and domestic. Yes, yes, with the new instances you start with a p of s, so it is a closed bracket, then star p of color equals to red bar s, again multiplied with the p of a type equals to SEU given test instances with a yes, again p of origin is domestic with a yes. So this is the yes, these are all values are there in the tabular column. Just apply those values and simplify, you will get a 0.024. Then similarly you need to find out the for a test cases, yeah, new instances with the no value. Okay, again you will get the value 0.027. After that you need to compare with the yes and no value. Here the no value is greater than the yes. See, 0.072, it is a greater than 0.024, right? So for that reason you need to mention that it is a greater one, so you are accepting this p of no value. Okay, then next question 6.1, analyze the student performance using the naive Bayes algorithm for a continuous attribute prediction whether student will get a job offer or not in the final year. So here the again based in the naive Bayes topic we have a numerical problem. If I start to explaining this again, you will get a confusion. So you just go through this PDF and solve by yourself. Okay. So that's it all about. Yeah, that's it all about module 4. I just focused on the model question paper and the previous year question paper questions. Yeah, guys. If you have any queries regarding about this module 4, you just comment below. Let's see to solve. Okay. That's it, guys. Thank you.